Qtira is an open source AI platform that has been designed to run completely in a local environment. So in this video, I want to give you a demo of this platform. So before I switch to the VS Code, I just wanted to highlight the capabilities it has. You can generate the data set from your documents that resides in your Google Drive or local drive. You can fine-tune an open source model from Hugging Face. The platform uses the Apple's MLX-LM library for that. You can author your own agentic workflows using CrewAI. You can design your business processes powered by N8N, and it also provides a vector store for RAG and semantic search capabilities. So let me switch to the VS Code. I've already cloned the project, and now I'm going to issue this command called start.sh. This is the only command that is required to bring the entire platform up. The platform is up. It takes around 2 to 3 minutes to build all the images and bring all the containers up. So let's go through the sequence of what the startup script does. First, it checks for the prerequisites. You need to have Docker Desktop, Ollama services up and running. The fine-tuning service, as I mentioned earlier, uses Apple MLX-LM library for the fine-tuning. So if you don't have an Apple Silicon chip, that one single service will be disabled. Rest all the services should be available. And then it tries to build the images for various services, and it brings up all the containers. And then it waits for the N8N to be ready. It tries to import the 6 workflows that is part of the platform. These 6 workflows, some are mandatory for the platform capabilities and some are examples. And then once the import is done, then in subsequent runs, it skips those import. And then finally, you have all your URLs ready and available. So let me open the front end, which is on port 3000. So this is a very simple dashboard that gives you a quick rundown on what exists in this platform. So here you have your system health. It gives you a quick view of the health of various components that's part of the platform. This is a simple graph which gives you an overview of how many agents, business processes, fine-tuned configurations, and datasets that you have created. So before I explain the dataset functionality, I forgot to mention one thing during the startup. When you issue the .start.sh command, the script will check if there is an .env file in the workspace. If there is no env file, the script will create an env file with all the default entries for you. There are only 2 things you have to change in the default env file that the script generates. One is the Hugging Face API token, and the other one is the file share path. Okay, so this is the path which will be mounted in the N8N container. And when you're going to generate your data set from local files, that file should reside within this location. Keep that in mind. So let's move on to the dataset generation. Let's look into the dataset functionality. So before I go into the dataset, I need to explain about the 3 N8N process flows that dataset functionality depends on. So let's click this process flow link. So it opens your N8N, which is part of the platform, which is running locally. So first you have to create your owner account, so you can give any email. It doesn't have to be a valid one. So let me quickly create my account. Okay. So once you have created the account, you should see the 6 workflows that was imported as part of the setup process. So initially all the workflows will be inactive. you won't be able to make the sub-process active because it has to be inactive because it doesn't have a direct input node. But before we go into this, we have to create the credentials. We have to create 4 credentials. I've mentioned that in the setup instructions in the GitHub repo. So the first credential is we need Ollama. So let's create Ollama. Instead of localhost, you have to say host.docker.internal because the N8N is running inside a Docker container, and then you just save it. Okay, the connection has been established here. Okay, the next credential is PostgreSQL. So let's go to the Postgres. Again, here it should be host.docker.internal. And then it should be the product DB. So let's go back to our env file. And it should be the product DB. So let's copy this. Product DB. Username is product user. And it's all generated by default. So either you can change it or you can use a different one. Doesn't matter. I think you have to change the port. It's 5432, but here it is 5434. So let's change the port. And you click save. Yeah, connection is done. The next one is Qdrant. We have to create a credential for Qdrant. That's our vector store. Let's click that. So for Qdrant URL, just copy paste the URL from the startup script. But one thing we have to change is the local host. We have to change it to host.docker.internal. And then next click save. Okay, this is done. Then the 4th account credential we have to create is the Google Drive's OAuth 2. For this video, I'll just skip it, but I have provided the URL for the setup in the GitHub repo. So let's go back to the workflow. So this is the dataset generator workflow when you have files in your local drive. So it has a webhook where it gives you an API to invoke the flow. It reads the files from the disk, and depending on the file type, it has a specific extraction method. It merges the output and then delegates it to the sub-process flow. Similarly, we have another process flow for Google Drive. Similarly, we have another process flow for the Google Drive. Again, it has an API by webhook. It reads the list of files from the drive, and depending on the file type, it downloads that file, extracts the content, and then it delegates it to the sub-process flow. In the sub-process flow, we split the text into 1000 character chunks, and then we give it to the chunk creator to break those chunks into a coherent block. We then give it to the QA generator to generate the question answer pairs. And then finally, we persist them in DB. Okay, the one thing we have to do here is we have to double click and we have to select the account credentials. So otherwise you will get an error icon here. If you see that, it means you have to double click on it and select the appropriate account that you just created. Make sure that your local drive active as well as the Google Drive. Once you create the OAuth 2 for Google Drive, make it active. You can leave the sub-process inactive. So now let's go back to the dashboard and let's click on the data set. So let's click on new data set. Let's give a name. I'll call it as AI recent advancements. Okay, I'll just copy paste the same. And then it is domain can be AI, local drive. So this is the path. I have a folder called recent_AI within the file path which I explained in the previous section of the video. Okay, so within this folder called recent AI, I have one small text file which talks about the coherence bottleneck that XAI broke. So it has a very simple text file. So I'm giving that folder name here. And the process workflow URL is the webhook URL of the local drive. So double click on this webhook, take this production URL and paste it here. And I'm going to use Mistral template, and then I'm going to create. Okay, so let's launch the dataset that we created. So it shows in progress. You can also verify the run when you go to the local drive. And then when you click on the execution tab, you will see the process running. Had a small minor issues when the previous runs, but now it should work fine. So you can wait, and then within a few minutes it should be done. Okay, now the process flow dataset generation is finished. You can see that the state has become active. So let's go back to the dataset generator and see what happened. Let's refresh the screen. The code went through. Let's go back to the subprocess flow and look at the code. Okay, it succeeded. Basically, it generated 4 question and answer pair. So let's go back to the UI. And then if you click on the view details, you will see the chunks that the process created. And when you click on each of this chunk, you will see the question answer pair that was generated based on the chunk. Okay, and then you can click all the 4 links and see the questions. Similarly, for Google Drive, make sure that you pass the Google Drive's webhook URL, and then the process should be the same. Let's look into the fine-tuning process. So let's click the tune link, and let's create the create configuration. So I had some issues with the models that were within the MLX community category. So let me remove that and let me search for Mistral AI model directly. And let me select the 7 billion instruct version 2. I've already downloaded version 3 and version 2. So for this demo purpose, I'll select the version 0.2. And then the next step is to choose the dataset that we created in the previous step. Let's click. And then we have to give a name for fine-tuned model. This is a name that will appear in the Ollama. So let's say my custom Mistral. My custom Mistral model. And then this is the path where the files that's downloaded from Hugging Face, the tensor files and all will reside. So this could be any directory in your system. And then let's leave the training split and iterations, everything as by default. Let's move to the next step. It's just reviewing all your settings. And then finally give a name for your configuration. Announcement. Finish. So once you've created the configuration, you have an option to launch. Also, you can tail the Celery log files in your command prompt to see the progress. So let's do that. So let me first launch the file. Let's go back to the VS Code. I'll say tail here. Okay, so we have the logs running. So now let's launch the process. So let's click the launch training. So already I've downloaded the model to save time. So I'll move to that step and move to the training. Let's go to the command prompt, and you should be able to see the iterations running. So we have value loss of 7.1, training loss of 4.3, and then the subsequent iterations, you see the training loss reducing. We are at 50 iterations out of 100. Let's go back to the UI and see the progress. Okay, now training is done. It's creating the model file so that it can be imported into Ollama. So Ollama is done. Let's refresh the screen. It should show completed status. Let's go back to the command prompt and let's test the model. So let me issue a command to Ollama and list the models that we have. So this is the model that we created just now. It's 25 seconds ago. So let me load this model and let's see if the model runs. So run. Okay, so let me say, give me a sonnet. This is just to confirm there is no corruption in the fine-tuned model. Okay, so the model seems to be working fine. So now this fine-tuned model, we should be able to use it in our agentic workflows and in our process flow. So let's go through the agentic workflow in the next section. We finished reviewing the dataset and fine-tuning process. Now let's move on to the agentic workflow. So let me create a workflow that mimics what's there in CrewAI. So let's do a workflow name. Let's say researcher. So let me give the same name. This is just the name for the workflow. So a model. So you can select the model that we fine-tuned, custom Mistral model. And then we can give a name. Let's say topic. And then we can make this as required. Let's go to the CrewAI GitHub. And then if you go to the open source page, you will see an example that's been given. So I'm going to mimic the exact example in our platform. Okay, so here if you see topic is the input parameters for this example. So I'm going to replicate the same here. So I've given the same name as topic. And it's going to be sequential, where agent is going to call the next agent in a sequential fashion. So let me save the workflow. Once you save the workflow, you have to click on this. The center button is for configuration button. Click on it. And this is where you add your agents. So let's click the agent. The first agent is the researcher agent. So let me copy that and say this is the researcher. And then the next is the role. It's saying senior data researcher. So let me click this topic is the input parameter. And then after that, I'll say it as a senior data researcher. And then uncovering the cutting edge developments in goal is uncovering topic, this backstory. And then let's create a task for that agent. So let's go back here. So this is the task for the research agent. So let's give the task name as research task. And then let's copy the description as is. This is the description column. And this is the expected output. And then you can click the next agent. This will be the second agent for that workflow. That will be a reporting analyst. So now let's save the configuration. So now we have configured the agents. We have given the tasks and so on. Now let's click this play button. So this is where you can test your agentic workflows. So we have one input parameter. So that has been automatically loaded. So we can give any topic that we want the latest research to be done on. let's say NVIDIA workflow. Okay. And check the progress if you go to the Docker, and if you click on that container, you will see the execution flow. So let me go to the Docker. So let's go to the workflow engine container and click on it. You would see the execution going on. So let's wait for a few minutes. Yeah, here we go. We got the output. We got the execution trace. And then we use token metrics. Remember, this execution is happening locally in Ollama. The token consumption should not concern us. This is about the agentic workflow. The next step, I'll explain how we can use this agentic workflow in your process flow, in the business processes, how you can leverage them. We have seen dataset, fine-tuning, agentic workflow thus far. The last item is the process flow. So let's click the process flow again. Here, let's look at the agentic workflow example that's part of the build. It's a very simple flow just to illustrate how you can use the agentic workflow in N8N. Though N8N has its own AI agents that you can drag and drop and use it. So this is an example of how you can have your own agentic workflows in the platform using CrewAI, and then you can leverage them in your N8N flow. So it has a chat message, and then it has a HTTP request node, which is basically invoking an API. Here we have configured the HTTP node to use a post method. The URL is pointing to our workflow engine API service, which runs on port 8100. The standard URI is execute. Currently, none of the methods are protected. And then it uses a standard JSON payload. So in this workflow name, we have to give the same name that we created here, researcher. So let's copy that. Instead of research organization, let's give researcher. And it accepts an input parameter called topic. So let's copy the topic. And let's give the name as topic. And whatever the chat input is, that is the value we are supplying it to the topic. Let's save it. And then let's give a topic. Let's say SpaceX Starship. As you may know, N8N has tons of integrations with various enterprise applications that you can readily drag and drop and integrate. So assuming that you will be able to create business processes, within that you will be able to integrate your agentic workflow in it just by drag and dropping your HTTP request and invoking the appropriate agentic workflow. Once the API request is done, the edit field is basically extracting the final output and displaying it to you. So this is the output that the agentic workflow has given us. Okay, so this is another way of how you can bring your CrewAI into your flow. The other examples that we have are update knowledge base. It is a very simple example where when you create a file in a specific Google Drive folder, that file will automatically be downloaded, and then it will be stored in the vector store, which is our Qdrant vector store. It uses an embedding which I downloaded from Hugging Face called Nomic Embed Text. You can download any other embedding models that you want in Ollama, and you can use it. And here we are using a default data loader and the recursive character text splitter. So that whatever information you drop it, you should be able to see it in your Qdrant vector store. The other example is RAG workflow, which I'll show it. Before that, we'll take a look at the vector store. So when you click on this vector store link, you will see the Qdrant's UI being opened. So currently there's no data. Once you populate the data in your RAG workflow, you should be able to test this workflow. It's a very simple, straightforward workflow where we have an agent and it has access to a vector store. It refers to the chat model, which we can change it to the model that we recently fine-tuned. Then you can test your functionality and how the information from vector store is being fetched for your processes. These are the capabilities we have in this Qtira open source platform. The image generator is just a simple, nice to have feature where you can provide your text and generate an image. Currently, it points to a Hugging Face model, but I suggest that you can download a model that can generate image, host it in Ollama, and then you can change the code to point to the local service, and then you can execute. That's all about the capabilities. Thanks for your time. I hope you guys like it.